Welcome to Talk Universe. I'm your host, Sir Charles Schultz, and this is our show for Wednesday, September 28th, 2016. Tonight, we have a very interesting topic, one that has caused no end of controversy and questions. And it's all about the Fermi paradox. The question in a nutshell is, where are our neighbors? Now imagine being in the Old West, and it's nighttime, and you're in the desert somewhere. And as you're sitting by your campfire, you look out into the night, and you look for other campfires. And sometimes, in the distance in the dark, you'll see one. But you don't always know if there is anybody there. Maybe it's not just a campfire. When we look up at the stars at night, we're seeing those distant fires, but we don't know if anyone is home. Because those fires are produced by nature. Our sun is one such distant campfire. All the stars, similar to our sun, are distant sources of light and heat and can have planets of their own. But we just don't know if anybody's home. So we listen, we watch, we look for some sign that somebody might be there. We don't know, when we look at the night sky, if there might be eyes looking back at us. And that is one of the interesting mysteries. We know that life should be everywhere in the universe, and we've known this for hundreds of years. But when we look at the night sky, we still see no definite signs that anyone else is there, and so we wonder if we're alone in the universe. The Fermi paradox is very simple. It was named for the physicist Enrico Fermi, who was involved in the development of the atomic bomb at the beginning of the 20th century. And he was very keen on this particular subject, and he asked, where are all our neighbors? It seems that they should be everywhere, and yet we see no signs of them. The paradox is very simple. Knowing that the universe is conducive to the generation of life, and that it should support life everywhere, we should be seeing our neighbors. We should see the signs around their distant campfires, their radio waves, their vehicles, something, and yet the skies remain silent. So where are our neighbors? Now it was suggested as much as a century or two ago that perhaps in order to reach out to people in space, to let them know we're here, we should plow our fields in huge geometric patterns such as squares, circles, and triangles, and then we would know that if anybody turned a telescope toward the Earth, they would see signs of intelligence here. Of course, that's rather an audacious plan and one that really wouldn't work. However, it was an interesting thought and a beginning. Back then they had no idea of the scale of things, and only recently do we really know. Today, when we look at what is possible, we have radio telescopes, and we know that there should be radio signals, or perhaps laser light, or pulses of X-rays, or ultraviolet, things that wouldn't make it through our atmosphere, perhaps. Signs of massive industry, the sorts of things that we as human beings, as we grow and expand, would produce. But our ability to detect is also an issue. We don't see vehicles because they're very tiny, and perhaps they don't leave the signatures that we think they would. After all, there are billions of automobiles in the world, but we can't detect the ones in Italy or in Africa from here. So, even though they exist, the signs of them could be very, very thin and difficult to see. So what do we see? Well, we listen, mostly for signs of industry, of course, because we only know that technical civilizations such as our own could produce radio waves or have radio telescopes in the first place. And that's an interesting consideration. There could be millions and millions of worlds where the people live in the plains or the grasslands, have no technology of any sort that we could detect. And those worlds would be silent unless we could actually go there or see some other sign of their existence, which is very unlikely for us at this time. Our technology, as advanced as it is, has its limitations, of course. There could be millions of worlds where they're water worlds, and the most intelligent life is the equivalent of a dolphin. No fire, no hands, no technology. And again, the skies would remain silent, and we would not know of their existence. Their music, philosophy, or creations would be something unknown to us unless we could go there. So what do? We have to choose likely-looking places to aim our telescopes. After all, our galaxy has between 200 and 400 billion stars in it, and that's just our galaxy. And yet only our nearest neighbors would give signals off that we might be able to detect. So we have to be smart about it. We know that small yellow dwarf suns such as our own could be quite capable of supporting life. After all, we live near one ourselves, and they would be good targets to look at. But they only make up about 10% of the stars in the sky. We also know that if we try to look at a whiter, hotter star, there are limits to how far we could look because hotter suns tend to burn up their fuel and vanish in a short period of time. They wouldn't last long enough for civilizations to develop and get anywhere. And conversely, there are stars that live longer than our sun. Redder or oranger stars would be quite clement for life, so we know that there are a number of orange suns in the universe that could easily support life. And those are fine. But when we look at the number of red suns, they make up almost 70% of the stars in the sky. Now, people would think they would be a good place to look. The issues are very simple. When you look at, for instance, an orange sun, we know that they are cooler and smaller than our sun, and a planet would have to be closer to it and its year shorter, and that's not much of an issue. But when we look at red dwarf stars such as Proxima Centauri, the nearest one to our sun, they're so dim, we can't even see it with the naked eye. We need a telescope. And the results of this sort of physics that we understand, the generation of heat and light and the size of a star, dictate that a planet near such a system would have to be very close indeed to be warm enough for liquid water. Otherwise, it would be a frozen wasteland. So, a star such as Proxima Centauri, a red dwarf sun, can live many, many thousands of millions of years, much longer than our own sun, which means it would be an ideal long-term habitat. But the downside is a planet around it would have to be so close that its year would only be about a month or even 2 weeks long. Now that's not so bad, but there are two major issues. If you were to live in a red star system, such as the nearby exoplanet around Alpha Centauri C, or Proxima Centauri, if you were to live there, you would be very, very close to your sun, and your planet would be tidally locked. In other words, its rotation would stop. It would be so close to the star that one planet's face would always be toward that star. You'd have a day side which was always broiling or in direct sunlight at high noon permanently, and you'd have a night side that was in permanent darkness, which might be so cold that much of the atmospheric gas would freeze out on the dark side. So these two poles would never see the other. Each side would stay either in permanent night or permanent day, and all the life in habitable zones would be in a ring around the twilight area of the planet. So you'd have zones of permanent high noon, permanent midnight, and permanent midday or evening. What an interesting place to live. It would only mean a part of the world was habitable. But there's another interesting side effect of red dwarf suns. They're flare-prone, and life could be wiped off of a planet very easily under those circumstances, or it would have to be very hardy and live underground. Now, if only 1 out of 7 red dwarf stars was a home of life, then it would double our potential candidates when we were looking at the number of only yellow dwarf suns capable of supporting life. So we know that there's a range of stars. Large, bright, hot stars burn their fuel out quickly and would explode long before life could reach any level of complexity or even before planets had finished forming. So we can narrow our targets down pretty easily. But again, we have to be cautious about where we're looking because we make a lot of assumptions. One of the assumptions is this. It was thought that since organisms are basically made of water-based molecules, that maybe they would use a signature that would allow us to recognize who they were. They would broadcast on a set of frequencies known as the water hole. These are hydrogen-oxygen oscillating molecules that give off a radio wave signature that's very easy to detect. The water hole is a favorite set of frequencies for those looking for extraterrestrial life. We made laws against broadcasting on those frequencies so that they wouldn't obscure signals from others, from aliens in the dark. However, what if they think the way we did and they made similar laws and nobody's broadcasting on the water hole frequencies? If only 9 out of 10 races thought about this the way we do, then we would only see 10% of the potential signals being broadcast. And that means that it's a bad place to look. Now, personally, I've thought about this, and I feel that if this was the case, maybe we wouldn't broadcast on the water hole frequencies directly, but perhaps on a mathematical product of, let's say, a natural constant such as pi or e or the golden ratio. In order for this to work, you take the water hole frequencies as a base, and you multiply it by a mathematical constant. Now the result is a unique radio frequency that would not be generated in nature by normal processes that we know of, and therefore that would be a first prime signal that this is a signature of life. Instead of looking at the water hole frequencies, we should be looking at multiples of them and natural constants or mathematical constants, then we would find frequencies of radio waves that would clearly and uniquely say somebody had to think about making this particular frequency. But there are other considerations. There are many signatures or wavelengths that can't make it through our atmosphere and could only be detected from space. And we don't have any large space-based telescopes. We have small ones, like the Hubble, and similar ones, like the James Webb Telescope. However, when we start looking at space telescopes, the very reason for putting them in space, to detect signatures that you can't see from the ground or in a noise-free environment, also means they need to be very large in order to be sensitive enough to detect these signals. This is an issue. We can't yet launch very large structures into space, and so we're limited by the size of our launch capability to what we can detect. So based on physics, we have a range of stars and star types that we should be looking at because they're most possibly homes of life and stable long enough for it to develop technologies. And we also have some idea of the sort of signals we should be looking at, and we've been looking in the wrong places really for a very long time. We also have some sort of an idea of what civilizations would be like. After all, we know that physics works the same everywhere, and radio waves would be one of the first signatures that you would look for from a growing civilization. So let's think about these things. Are there other signs we could look for? We know that if a civilization reaches a technical stage, it's going to be interested in sending space probes out in all directions and learning about the universe. And one of those sorts of devices is called a von Neumann probe, a self-replicating robotic machine. If you launch these in all directions in our galaxy, in the space of roughly 1 million years or so, one civilization would have placed replicating probes in every solar system of our galaxy. Now, we don't yet see signs of these, but they could be remaining silent and dormant in our asteroid belt or other places. And the universe could be a very busy place full of these machines everywhere, creating a network sending information back to their parent suns. So in a nutshell, here are some things we need to consider. Our strategy has been to listen, although we have sent a couple of intentional messages into the dark. And we have a fair idea of where we should be looking, and we see some interesting signs from time to time. We've had about 250 radio signals that appeared to be legitimate but not repeating, and some have been dismissed as spy satellites or other hardware. And that's understandable. But you see, there are different types of civilizations, and we need to look at that. And we also need to look at things that perhaps could end a civilization. There are many things in the universe that will kill off life on a planet, and there are also things such as warfare or nuclear disasters or biological disasters that could wipe a civilization out from the inside. They could be destroying themselves. We reached a point where we were very close to it. We also have to look at the positive signs and implications if we are alone in the universe. Or if we do have neighbors, both of those things lead us to some very interesting conclusions. And we need to think about those things. What if we are alone in the universe? What would it mean? There could be so many civilizations that never reach the technical stage, and we can't hear from them, and they don't leave a mark that we see. It's possible that mankind might have reached a point just after the Ice Age where development was occurring and civilization was growing and people were spreading, and then an asteroid hit the planet, or another ice age set in, or any number of things could have happened, and we could have been wiped out. So, silence from the dark means a lot of things. But there's another way of looking at it. We're depending on the detection of radio signals, for instance, and we know that as our technology has changed, radio signal generation went up, and the output of our planet soon equaled and surpassed all the radio noise generated by our sun. But now we're getting silent again. Fiber optics, packet radio, short-haul radio, broadband signals. Our Earth is now becoming a radio-silent place, and we would need to catch civilizations in their peak when they're making lots of radio waves. Now we're moving to a point where, perhaps with quantum communications, we won't be broadcasting anything at all. And what would that mean? Maybe the universe is silent because we're not looking in the right places, or it's something that we cannot detect. Quantum mechanical communication. So there are a lot of implications and a lot of things to think about. We'll get into a lot of that in a little while here on Talk Universe. And types of civilizations are at the top of the list. I'm Sir Charles Schultz. Keep listening. It's said that there are approximately 200 billion stars in our galaxy. Some say more, some say less. But out of those stars, about 10% are yellow dwarfs like our sun, and there's probably another 10% or so that are orange or red stars that could be habitable, or their planets could. So that gives us 40 billion solar systems to think about. And let's say the odds are that 10% of those develop complex life. Then that would be 4 billion potential candidates. And out of that, let's say that 10% of those survive environmental disasters such as asteroid impacts or ice ages or solar flares. So that gives us 400 million candidates with life systems. And out of that, let's say 10% of them developed intelligence. That would leave 40 million civilizations, solar systems with intelligent beings capable of developing technology and having histories and warfare and ships. 40 million potential civilizations, but we also don't know, out of those, how many of them have reached a point where they could do technical things, or how many don't kill themselves off through nuclear warfare or biological disasters, or we just don't know. But if you think about it, 40 million civilizations, or even if only 1 of 10 made it through that gauntlet, 4 million civilizations. Some would have come earlier in the history of our galaxy, some later. Some would have been long gone. Some are only here now or just showing up. But that's an awful lot of civilizations. Somebody, somewhere, should be making radio waves. Why don't we hear them? One issue for SETI is this. If they detect a wave one night and then don't get the repetition a night later, they often simply discard the signal. But stop and think. Our planet has a day of 24 hours. Maybe their planet has a day of 17 hours. When you go back looking at the same spot 24 hours later, you could be 7 hours too late. You see, we really don't know. Planets of all length of day exist in the universe, and a civilization could have anything to deal with in terms of day length. We might never see a repeating signal for that simple fact. Unless they're doing it from space, it's very unlikely we'll see the same thing twice. And so we discard so many signals that might be valid as a result. So what types of civilizations could there be? Well, we all are aware of simple things such as grasslands, horses, huts, nothing of technical natures. And civilizations of that type will be things that will be next to impossible for us to detect. We might as well forget about them. But of those, what about the technical civilizations? Of course, we know about the Victorian-era steam engines and large mechanical devices, and people seem enamored with steampunk. What an interesting trend, combination of high-tech and steam machinery. Those things could exist everywhere as well. When we get into the technical side of things, we think past the atomic age, into space travel, possibly nanotechnology, and the advances pile on very, very rapidly. We're approaching, after all, the singularity. So when we think about these sorts of civilizations, we begin to realize that there are scales of magnitude, and there are things called the Kardashev scale of civilizations. Basically, a Type 1 civilization is one that has reached the ability to completely control their planetary environment. Everything on their world is subject to their whim. We, as humanity, are probably at about 0.7 or 0.8 on that scale. And we have a long way to go before we even reach that first level. There are other possible developments in the civilization's technical expertise and ability. When we really think about it, we have the ability to gather, let's say, solar power, but what if we wanted the entire output of our sun? We would have to build structures larger than worlds in order to do that. And we see some signs of what might be that sort of civilization around us in a couple of locations. Suppose you were looking at a star and you noticed that its light level went up and down at a regular basis. Now, normally you would simply say, well, the nature of that star is simply that it pulses as it's consuming its fuel, and we see that as a regular rhythmic change of its intensity. But there's another way that could happen. Suppose you wanted to, again, capture all the output of the energy of your sun, and what would you do? You would literally build a shell around it, a bubble, that completely enclosed your sun and allowed you to take advantage of all of the energy that it produces. This is called a Dyson sphere. Basically, the bubble is as large as the radius of your planet's orbit would be, and at that distance, you can capture all the energy and use it for everything you wish. You would spin the bubble, and it would give you an internal gravity field of a sort, and you could have zones of atmosphere that were millions of times larger than the area of the Earth. You basically would have an unlimited room to spread out and grow and develop. But there's an interesting side effect of this, and that's the following. As you begin to build the structure, and you begin filling in the floor, it's rotating around your sun, and people in other solar systems, when they look in your direction, see your sunlight being blotted out by the sections of floor in your rotating shell. Now, they might conclude that simply that star is a variable star and it pulses as it changes its burning habits. But maybe it's something else. Maybe this is a civilization so big that they have disassembled the planets and material in their solar system and built a shell around their star, and we're seeing the light flashing as it rotates. Civilizations can be incredibly powerful, at least in theory, and this is potentially one of those technical developments. We have a couple of candidate stars we're looking at right now where this has been proposed as a possible mechanism for seeing the light rise and fall from those stars. We need to keep our eyes open and keep listening. This is an interesting sign. But we don't see signs of those giant interstellar civilizations like you see in movies such as Star Wars or series such as Star Trek. And there could be very good reasons for that. Maybe travel faster than light isn't possible, or maybe it's very hard to do, or maybe it's inconsequential. Perhaps you reach a certain level where you can do everything by other means and you don't need to travel between the stars and giant spacecraft. So there are many things to think about in that regime as well. But now we know that there's another type of civilization, and the Dyson sphere takes you to a Kardashev level 2. You can control all the resources of your solar system. But a level 3 civilization would be one so immense that it could effectively capture the entire energy output of a whole galaxy. And we see no signs of that, although it sometimes is troubling that there are whole dark galaxies that we spotted in our universe, and maybe what that is a Kardashev Type 2 civilization that is spread throughout their galaxy and is now putting Dyson spheres around all of their stars. And that effectively would take them to Type 3, really. There could be civilizations so ancient and so well entrenched and advanced that they would be godlike in their abilities. We would have no idea what they're like, really. We can't even imagine what's going to happen on the Earth in the next 20 years with the growth of information and computing and possibly AI. Would an organic brain be capable of functioning in a civilization like that, being a useful member, or would it all be machine intelligences? And why is it so quiet? Maybe there are other things in the dark, products of technical civilization, that make that happen. There was an author by the name of Fred Saberhagen, a science fiction writer, who came up with the concept of war machinery, programmed to kill all life, and a battle between two civilizations, and in the end, the Doomsday device was released. Machines that would simply wipe out everybody. And they could be out there in the dark, growing and reproducing and waiting for radio waves from a new civilization, after which they would converge on them and wipe them out. That's a chilling thought. There could be enemies in the dark, tireless, pitiless, running on whatever resources they could find, growing and developing and waiting for the next victims. Or maybe it's something a lot less sinister. There are things out there besides civilizations that can wipe out life, and we're surely aware of, and we'll get into a lot more of that very shortly. But types of civilizations, there's such a broad range. You go all the way from wandering the plains and weaving grass baskets to building radio telescopes and starships, and then possibly shells around a sun. And all of these things have intermediate stages as well. We do see some signs that might indicate that there are some very powerful civilizations in our galaxy. But nothing is very definite or clear. And the lack of radio waves is puzzling, if not troubling. But if we were using quantum mechanical communication, of course, we probably wouldn't detect any signs of that. Now, it's also quite possible that civilizations, instead of sending large machinery, would send nanotechnology, dust-like probes moving near the speed of light that would spread out to all the different solar systems and give them a means of carrying out their will that way. And I don't know for certain, but if we reach a point where nanotechnology can be sent to other solar systems, and if we can include quantum mechanical methods as well, we might be able to establish a form of communication, perhaps instantaneous, between all the different star systems, and send and receive material basically the way you send a fax. Imagine sending an idea using quantum mechanical methods so it travels the stars' distances instantly or nearly so, and being able to construct anything like 3D printing or literally growing it out of the resources around you using nanotechnology at the other end. In this scenario, you wouldn't really need to travel from star system to star system. You would simply communicate through your QM network, your quantum mechanical network, and read what was present in the other solar system and construct any structure you wished by sending the instructions to your probes already present in that system. So this is a system that would allow somebody to basically take over a galaxy, or at least establish a large number of outposts and the ability to get information all over very quickly. This is something to consider. We have no idea what's possible at this time. We only know that the more we discover, the more we find out we didn't know. And, it's not unlikely that there are means of getting around that we're not aware of. In fact, I'm sure of it. We didn't know about automobiles 200 or 300 years ago, and they are a major force on the planet today. We felt that animals, like horses, would be our major source of transportation all the way up till the end of the 1800s. And then when the automobile was invented, it changed everything radically. So what other sorts of inventions would be come up with by advanced civilizations? And communications technology is no exception to that. It's very clearly included. We found a number of new ways to communicate we didn't know about a couple hundred years ago. So we can expect that there can be messages flying from world to world that we have a total inability to detect or make sense of. And the other issue is there's a great deal of radio noise out in the cosmos that probably is from control systems, garage door openers, whatever, cell phones, any sort of technology that uses RF could be broadcasting broadband signals that we don't have the digital key to unlock, and it could be that as much as a quarter or more of the radio noise we detect from the sky, which comes from all directions and appears to be sourceless sometimes, could very well be just a hodgepodge of all of these signals mixed together. And because they're so weak and because we don't have the right broadcast decryption key, we can't make any sense of them. And that's a real and serious possibility. Now, somebody mentioned something to me a little earlier today about crop circles. And, it doesn't seem to make any sense to me that a civilization with the power to travel light years to another solar system and get there safely would then find, hey, there's intelligence here, and we're going to stamp on their wheat. That doesn't make any sense. If you have the wisdom and the knowledge and the capability of traveling between the stars and getting to another solar system where there's another intelligent life form and you want to communicate with them, that's what you do. You get on the radio or you get on the TV or you walk right down in front of the White House lawn or the Kremlin and you make yourself known. You fly in formation, you do something obvious. You don't play around by stamping on their crops. That's not a way to get a message across. Now, we are a young and upcoming civilization, and what we become in the next few years may very well answer all of our questions about why we don't hear signals from space. We may find those signals in forms we didn't expect. We may find that the universe is mostly empty for some reason. And this is something that we have to consider. Maybe something is killing off most of the life in the universe, and therefore intelligence is very rare. Or maybe it's rare for other reasons we're not aware of. Or maybe there are reasons for intelligence to remain silent when they reach a certain stage. Perhaps we are simply beneath consideration. So much to think about, and so many subjects to cover. And we will do that in the next two segments, where we talk about world killers and what can wipe out life in large areas of a galaxy very effectively. And then we'll proceed from there. This is Talk Universe. So what sort of event could actually wipe out all life on a planet? There are a number of them, and our galaxy is not a peaceful place. Our stars are moving around this central whirlpool, slowly but constantly, and mixing with all the other stars, and we pass through different stellar neighborhoods. Many of them have some pretty dangerous events going on, so it means that during the course of the lifetime of a planet, it is exposed to many different hazards. In our short human experience, we don't see much of that. We only know this short clement period of time where life has been pretty good. But other things happen, and those are what we have to examine right now to understand a little more of why we might not have as many neighbors as we would expect. You see, we know that life should be common, and we know why it should be common. But we also know there are many reasons why life could be wiped out in a lot of cases. And unless we have some statistics, some idea of how common that is, then we really don't know if that's going to have a big influence on why we see so few radio sources in the sky. So let's examine some of those possibilities. And keep in mind that at any time, some of these events could occur to us, so that our future is not assured. We know that these things happen all the time. I'll bring a few of those out, and some of them are things that we have actually discussed in detail or seen in movies. And I think that this is something that we really need to look at. Well, first of all, obviously we could have some severe climatic change. The planet could get too hot or too cold rapidly for a number of reasons, and many of them have nothing to do with what happens on the planet. Sometimes it could be as simple as natural shifting of the pole over time. As the poles become more vertical, the planet tends to get more and more into an ice age. When the poles tip down, then sunlight can heat up those poles and evaporate materials that snow down there and can actually make the clement conditions return, the end of an ice age. So the wobbling of the pole is something that has a great influence on our climate and can happen on any other planet. One of the greatest dangers we face is that of asteroid impact. Meteors, asteroids, things from our asteroid belt could come to the Earth at nearly any time, but there are also asteroids that come from farther out in the darkness, the Oort cloud, that shell of material orbiting our sun. And realize that every star is likely to have an Oort cloud, and that would mean this material is out there orbiting in the darkness at a great distance. And as we travel through space and we become closer to other stars, our solar system runs headlong into that other star's Oort cloud. So there are, large bodies, small bodies, all sorts of things orbiting other stars. And as we travel through space, we can run headlong into those things and have no idea that they're ever coming. And they can come in very, very quickly because stars have, in many cases, big differential velocities. I might be moving pretty quickly, but I seem to be standing still to me, but the other guy seems to be racing along. Now, there's another indignity, and that is comets often come from the Oort clouds, the outer regions of a solar system, and some of those comets can carry significant quantities of cyanogen or cyanide, and if the comet were to strike a planet and also dump that load of chemicals into its environment, you'd have a double hit, and that could do irreparable damage to an environment that's supporting life quite successfully. We know that there have been numerous mass extinctions in the past on Earth, and some of them appear to have been driven by asteroid impacts. And it's interesting because in one case, at least 95% of the life on Earth was wiped out. And it took time, great periods of time for those species to recover. And most of them never did. All the things that we see are the descendants of only those things that survived the impact. So life is tenacious, but it certainly would stop a civilization from going anywhere. You may still have organisms around, but none capable of making radio waves. And this is an important consideration here. We could suffer from a near miss from some massive body passing through our solar system that might shift our orbit, and that could cause devastation. Now, it would be a gentle process, but the climate would shift greatly. And again, it's just remaining at the proper temperature for your environment to function for a very long period of time without disturbance. Solar flares are another issue. Our sun is not flare-prone. It's actually settled down nicely, and it seems to be fairly quiet. We sometimes get coronal mass ejection or flares, and they seem to mess with our power grid or our satellites, and that is a consideration as well. But they're not showstoppers, and yet a large flare could certainly do it. One of the things I mentioned about red suns is that they are flare-prone. So even though it might be a clement place for life, a good place for life to be, a good flare every now and then is all it would take to set you back. And even a budding civilization might not be able to survive the effects of massive solar flare or two. And I know that it would do a lot of damage to us here on Earth. Passing stars, as I mentioned, could have a lot of influence. One thing we don't really talk about a lot, and yet it's been addressed in movies and science fiction, is a star could pass through our solar system at close proximity, and it would cause immense disruption. I don't even need to go there. We're passing by stars constantly as our sun travels through the galaxy, and one close enough to our solar system certainly would mess up all of our orbits of our planets. And there are free-floating planets in the dark that live in the eternal darkness between the stars, icy, frozen worlds that wander at random and do not orbit a sun. And they may have been formed there, they may have been ejected by another star at some point in the past. And it's only speculation at this point how many there are, but we do know from watching the stars through telescopes that sometimes something unknown obscures or blots out a star, and often it is a rogue planet floating in the darkness. And so something like that is common. We just don't know how common, but they certainly could cause a lot of trouble. Molecular clouds, there's another one. We see stellar nebula floating in space. We see nebula, huge clouds of dust and gas and organic molecules floating in space. And yes, they're very, very thin. They're nearly a vacuum. And yet, if you lived on a planet or a solar system that was passing through one of those clouds for a significant period of time, they could dump immense quantities of molecules into your environment, such as methyl alcohol, which is pretty good at fixing and killing organisms. So you wouldn't want your world passing through a 3 or 4 light-year wide cloud of organic molecules. The effects at any given time would be small, but cumulatively they could poison an environment, and that's something that would certainly quiet a growing civilization. How about organisms from other biospheres? It's quite possible, and we've seen examples of this. We have meteorites from the Moon and from Mars that have landed here on Earth, and that's been confirmed, that big impacts will strike a planet and blow pieces of them off, and they orbit around in the dark for some period of time, millions of years in most cases, and can then make their way to another planet and land there. So we have actual meteorites that are samples of Mars, but they've been, sterilized on their surface by re-entry. But if something had survived and been inside that rock, then it might have made it. And hardy organisms can do that. And here's an interesting thing. Some of those organisms might be infectious to the environment they land in and can spread destruction. So it would only take one small organism that, let's say, sets up the base of its food chain in the ocean and disrupts the existing food chain because it might be a little better at eating and reproducing. And your ocean ecosystem and the basis or the fundamentals of life on that planet could be displaced or destroyed. And even if it only was 50 to 70% effective, or even 30% effective, the damage it could do would be huge. And so it could be a showstopper for civilization very clearly. Now we get into the more, energetic events. We all know what a supernova is. When a star burns out its fuel, there are a couple of ways it can go. And small stars will simply collapse. They'll burn their fuel out, they become dimmer, and settle down as basically a cinder for millions or billions of years cooling off. But a massive star or a more massive star can reach a phase where it becomes a nova. And this is because as it burns out its fuel and it collapses inward, the pressure of the inrushing material raises the temperature in the star until it begins burning helium. It's out of hydrogen. What does it have to burn? Well, as this inrushing material ignites the helium, a second wave of fusion starts, and the sun begins to explode outward instead of simply collapsing in. And this explosion that results is called a nova if it's not so energetic, and a supernova if it's a massive star. And they make all the heavier elements that spread into space and form the planets around us, and life, of course. A supernova explosion is so energetic that if one were to happen within 300 to 500 light years, it could destroy a biosphere. So now we have an event that goes off like a flashbulb and sterilizes or destroys the biospheres of all the nearby planets and other solar systems around it. We have a couple of possible candidates that we're near right now, red giant stars that could go at any time. And so when we look up at these stars like Aldebaran is the red eye of the bull in Taurus, the constellation Taurus. It's near the end of its days. And understand that Aldebaran is not a threat because it's only 65 light years away, but it's shifted peacefully to burning helium, and yet it's just an example of a red giant star. It's really an orange giant. And Betelgeuse, some people call it Betelgeuse. It's from Arabic. Betelgeuse is the red star that is very, very possibly ready to go. It's about 540 light years away by estimations. And to be honest, some of those numbers go as low as 430 light years, some as high as 640 light years. So, the happy medium is usually what's picked. 540 is a good middle figure. There is Antares in Scorpius, a giant red star, and it could go. And if any of these were to go, it would have a huge impact on our environment. And we've got another one, Arcturus, which is less than 40 light years away, 37 light years away. It's a red giant sun as well. This could be the end of civilization on the Earth quite easily. So that's something else to consider. We don't even have to be near the event. And this is what's really important. There are events that can wipe out the life on a planet or a civilization at a distance, and you can't see these coming. And there's nothing you can do about it. Because realize that if you see a supernova in the sky from a star that's 300 light years away, that event happened 300 years ago, and its shockwave has been on the way all this time. And we're plowing right into it, and we don't even know. So we try to learn a lot about the stars and their histories and how they work, because this is something we might be able to predict. But there's even more. When a massive enough star collapses and forms what's known as a neutron star, the neutron star locks its magnetic field in, and it's usually wobbling like a top. And so the magnetic field does not just stick up and down on the polar axis of the rotating star. It can be off-center quite a bit. And we see these pulses of radiation like a flashlight or a searchlight from a lighthouse spinning around wildly. And these beams of radiation can be what's known as synchrotron radiation. The magnetic field of the star is shooting out a beam of lethal radiation. And the star is spinning so rapidly that it can do this 500 to 1,000 times per second. So imagine this rotating top, and the direction the top's axis is pointing is a beam of death. And a solar system that's being swept by this beam would certainly feel the effects. Any life-bearing world within, it could be 1,000 light years of such a thing, would be wiped out. So imagine the flash of the supernova or the sweep of the synchrotron beam from a neutron star, a pulsar as it's called, and this beam would sweep through your environment, and the skies would suddenly become blue-white with this brilliant gamma radiation that's generated by this beam, and the atmosphere is set on fire. Any oxygen in an area that is just lightly touched would turn to ozone, and the fires would race across your planet, and everything would be consumed very quickly. And we'd never hear of a civilization where this had happened. And I haven't even gotten to events of a non-natural nature, such as perhaps a powerful race might wish to terraform your planet. And that's way outside. That's simple speculation. The handful of things that I mentioned before are really the things we need to worry about, because nature is constantly sterilizing and wiping out living environments on other worlds if they exist. Because again, this is a dangerous universe, and our galaxy is not a peaceful place. And our solar system is moving at random through some of the worst areas that you really wouldn't want to go through. Nothing in the world we can do about it. And maybe that's one of the things that prevents civilizations from reaching out to us. Maybe most of them have been wiped out. So we can imagine a lot of natural disasters that can destroy a planet and its biosphere, or at least set life back so far that any growing civilization would have real disadvantages in front of them. And it's quite possible that there are many millions of civilizations out there. In fact, it's expected. But the question is, why are we not hearing from them? And so this could be a major part of why. Nature is destroying biospheres constantly if they exist, and the conditions in nature are not very stable. We live in a position of privilege on our planet where it has been relatively calm and quiet for the last few thousand years. And because of that, we've assumed that it's always this way, but don't be fooled. Our planet is not a peaceful place, and constant change is the rule. We've been very fortunate to live in some somewhat peaceful times. This is Talk Universe. So when we really start thinking about it, there are a lot of things to consider looking at life in the universe overall, and some conclusions we can draw. We know there should be perhaps millions of civilizations in our galaxy, and many will be much younger than us, and many will be much older than us, those that make it. We know that pre-technical civilizations we won't be able to spot because they're not generating radio waves or signals of some sort that we can detect. Technical civilizations will, of course, have things that we might be able to detect, in many cases, if they want us to. Some could be sending signals that you can only pick up if you have things outside of an atmosphere like space telescopes. They could deliberately choose wavelengths to broadcast on that won't make it through our atmosphere. It's quite possible that there's a whole network of communication going on in our galaxy at very slow speeds, but carrying dictionaries of information from civilization to civilization, kind of like those markers on the side of the road that have historical sites pointed out. We could find dictionaries, physics, maps, cultural material, anything buried in radio signals that we might detect, or any other sort of signal. Nevertheless, we also know that there are many natural disasters that will destroy life or set a civilization back. Realize something. All the things that happen in the universe outweigh what happens on this planet by many, many orders of magnitude. If our solar system could be represented by a single grain of sand, and you were to go to a basketball gymnasium and fill the floor a meter deep with building sand, and pull one of those grains out and paint it blue, and it represents our solar system, and then throw it in that sand and mix it in, your chance of finding it would be very, very slim. That's about the scale of the stars in our galaxy versus our solar system. Everything that happens in the universe really happens out there and affects us on the ground. And no matter what world you're on, that's a fact. The big events happen in the sky, and we just get the fallout. So natural disasters might set back or wipe out many civilizations. We might have signs of some really advanced civilizations, such as some of the stars that change intensity rapidly and regularly. This could be a natural phenomenon we don't understand yet, or it could be somebody building a sphere, a bubble around their star, and it's rotating and we're seeing the floor get in the way. And so the flickering of the light might be really big construction. But remember, the main event is in the skies. Why are we not hearing the signals? We're obviously not looking in the right places for some of this. We could greatly improve our odds if we get off the waterhole frequencies and follow things that make more sense. And as I mentioned previously, you pick a natural constant such as pi or e or the golden ratio, and you multiply it by the base frequency of the waterhole, and you look at that wavelength. You look at those frequencies for intentional messages, because that's the only thing that really makes sense. It would show intent, the use of mathematics and the use of thinking to get to that frequency. So there's a real issue right there. But what if we did find life? I mean, could signs be in our solar system? Well, yes, it could be. And as mentioned before, there are machines we can make, von Neumann probes, machines that could be launched to another solar system that, when arriving, they eat the natural resources they find and make copies of themselves and spread out, almost like a virus. This is an interesting concept, and any civilization with this sort of technology could have a probe in literally every solar system of the galaxy in a million years or two, which is short on the geological scale of things. And as a result, we should expect that any technology used in this manner would leave traces behind. Any civilization that sends out von Neumann probes would end up infecting every solar system, and I say infecting lightly. It would end up putting a probe in every solar system. And there could be 10, 100, a million different representatives in our solar system now. But you're talking about something that's not as big as a battleship, probably not even as big as something you'd hold in your hand. If you really look at the technology, it could be as small as a pebble, as small as a needle, or as small as dust. It could be on the scale of nanotechnology. Now, the energy to launch nanotech hardware to other solar systems is within our grasp right now. And all we need is the method of creating a nanotechnology probe smaller than a dust speck, smaller than a blood cell, and launching buckets of them in all directions of the sky, and they could reach all the solar systems in our galaxy very, very quickly. So this isn't something outrageous, but we would never be able to find something like that. So we could have emissaries, of a sense, in our solar system. But man, where do you search for something as small as a dust speck in something as large as your asteroid belt or as large as space? it'd be next to impossible to find. So, in conclusion, I'm certain, and many scientists are certain, there are millions of civilizations out there. Many of them probably pre-technical. A handful maybe make it to the high-tech stages. We are well on our way, but there are no guarantees. A disaster could occur at any time that wipes us out. And our only defense that we can mount, the best we can do, is to get some colonies started on other planets in our solar system or in free space and try to spread out so that nothing disastrous on our planet will kill everybody. Now, that isn't a fix-all measure. It's a stopgap only. Giant solar flare could still wipe us out. A nearby supernova could. Nevertheless, if we had colonies off-planet, humanity would have a fighting chance. We could fight through it. We might be able to do something about disasters that could wipe out, let's say, just the Earth. Biological disaster, an asteroid strike, that sort of thing. We can work around that if we just get a little head start on what we're doing right now. Is there alien life? Undoubtedly there is. There are quite many signs of it in other places. Our solar system has probably 5 other worlds, moons and planets, where those signs of biology in the form of liquid water and organic molecules do exist. So yes, I would say without a reservation, there's certain to be some other life in our solar system right now. And is there life in the universe? Well, considering the answer to the previous question, I'd have to say it's guaranteed. The most common life in the universe is probably bacteria living within planets, inside the rock, eating minerals, anaerobic, not requiring any oxygen, don't necessarily care about sunlight or radiation. They live on the heat and chemistry inside the ground, and that's a known process here on Earth, chemosynthesis instead of photosynthesis. Just the same, is it somebody we want to talk to? In my estimation, bacteria aren't great conversationalists. I could be wrong. I'm sure there are people who talk to them all the time, but it's on the order of the crop circles question. You're not going to get a great answer. But we need to keep our eyes open, because in the same way that there could be alien hardware in our solar system now, contact could already have been made in ways we're not aware of. And so, let's put our best foot forward. Let's be who we are, or let's be who we aspire to be. Because eventually, someday, we will meet other intelligent life. And what do we want to present to them? What face do we wish to show? That is the question. Who are we as humanity? Now, a simple thought experiment has occurred to me, and it's based on thermodynamics. We know that when you measure the temperature of a system where the sun is shining on it and other things are happening, and it reaches some terminal temperature, some final value, you know that the amount of heat coming in and the amount of heat going out are in balance, that they're exactly the same, or that would not be the temperature of the system. The same rule, the thermodynamic rule I mentioned, could be applied to intelligences. We know that intelligent civilizations, technical civilizations, should be emerging at some known rate, naturally. We also know that there are natural disasters that could be wiping them out just as quickly. Now, logic dictates that if they were being wiped out more rapidly than they were developing, then we would see no technical civilizations anywhere. On the other hand, we know that if technical civilizations were emerging faster than nature was wiping them out, then they would dominate the skies, and it would be a very noisy place indeed. What I propose is possibly the rate of emergence of technical civilizations must equal the rate of their destruction by natural disasters. In other words, if we could figure out how commonly these natural disasters occur and how fast they're wiping out those civilizations, we would know how rapidly they were emerging. Just a thought experiment. For our Singularity Watch, I have a fascinating article on earthquakes and artificial intelligence. Some research being done on a number of earthquakes, particularly the one in 2015 that happened in April in Nepal, showed that some interesting things happened, and they were observed and recorded by atmospheric scientists. This is an interesting thing they've discovered called the lithosphere-atmosphere-ionosphere coupling element. The lithosphere is the upper layer of the Earth's crust, the rocky portion of the globe that we walk around on. And of course, everybody knows what the atmosphere is. The ionosphere is a layer of the atmosphere above the part that we live in and breathe. And what was discovered was that certain gases were being released, and they're inert gases such as radon, before an earthquake and before aftershocks. Now, this is a fascinating discovery. Inert gases can be ionized and will reflect radio waves, or they'll change the amount of infrared light passing through the atmosphere or being reflected back. So atmospheric scientists were measuring these inert gases, and they found a sharp spike in the infrared radiation they were detecting 3 days before the April 2015 quake in Nepal, and 8 days before the aftershocks had occurred. The theory is that movement of the Earth's crust, the lithosphere, releases some of these gases. They go into the atmosphere, and then they travel to the ionosphere and become ionized, and they change the reflected and refracted infrared radiation. So both the major quake shock waves themselves and the aftershocks released these gases, and they were detectable. Now, 2 companies that I've become aware of, GeoCosmo and TerraSeismic, are both working on artificial intelligence programs that will sift through the records of thousands of earthquakes and begin looking for these signatures, and then develop a predictive model. If this works out, we can combine what we also know about Earth movements and the ground waves that we use to detect earthquakes. And by putting these 2 analysis tools together, we should be able to make some predictions of earthquakes a few days in advance. This is a major step forward in, if not controlling, at least understanding and getting a warning to some of the dangers of the planet that we live on. What an amazing advancement. Now, my book recommendation is, of course, right on topic. It's a book I read a number of years ago and really enjoyed. It's called Is Anyone Out There? And it's published in 1992. It was written by Frank Drake and Dava Sobel. Frank Drake is, of course, a scientist who worked early on with SETI, the Search for Extraterrestrial Intelligence, and it tells about the 30-year history of the project and many of the things they've discovered and what they were thinking. And it's an interesting and very lucid exposition of it. Dava Sobel is a science journalist, and she worked with him as co-author, and they've put the story together in an entrancing way. It tells a lot about what their early thoughts would be, life in the universe might be like, what they would expect. And Frank Drake is also known for developing what's known as the Drake equation. In it, he figured how many stars there were, what the percentages would have planets, would develop life, what percentage would go on to develop civilization, and what the lifetime of a civilization might be, because they were very aware, acutely aware, that at any time the button could be pushed and nuclear war could have wiped out mankind. And that isn't a threat that has vanished entirely just yet. But this story really lays it out clearly and understandably, and it talks about such things as the WOW signal, which looked like a clear signature of alien intelligence a while back. But even now, they're not entirely certain what it meant. So it's an excellent book. And you may notice at the beginning of the show, I gave some percentages of solar systems and life and so on. And that, I must say, was a derivative of the Drake equation, so I have to give him credit for that concept. So if you really want a good read and you want to stay on topic with the show tonight, Is Anyone Out There is an excellent book to read, and I think that I would recommend it strongly. My closing remarks for the show tonight are very simple. Think about what it would mean to you to discover alien life. If you were to find that life was common in the universe, and it doesn't even have to be intelligent life, but just the fact that there would be organisms anywhere, what would it really mean to you? Would it violate some of your fundamental beliefs? Would it throw your religion in a tailspin? What exactly would be the results of discovering factual evidence of alien life? Because you see, we're certainly not the only life in the universe. It would be ridiculous to think that this structure that appears to be 94 billion light years across and full of something like 1 times 10 to the 24th power stars, if not more, and that's a trillion stars, that we were the only life in existence? It is inconceivable, to coin a phrase. There are worlds of possibility out there right now, and even here on our own planet, no matter how bad things seem to get, remember, we can always make the world better. Remember the wise words of the Scottish grandmother who said, "Make you the world a better or more beautiful place for having lived in it." Take those words to heart, and remember, we have everything we need to make everything we'll ever need. This has been Talk Universe. I'm Sir Charles Schultz. Have a great evening.